In each of 3 through 15, a sequence is defined recursively. Use iteration to guess an explicit formula for the sequence. Use formulas from section 5.2 to simplify your answers whenever possible. T sub k equals t sub k minus 1 plus 3k plus 1 for each integer k greater than or equal to 1, and t sub 0 equals 0. So with iteration, the way we're going to do this is we're going to evaluate the next term, t sub 1, in terms of t sub 0, but we're not going to plug in 0 into t sub 0. We're just going to leave t sub 0 as is. So according to the recursive definition of the sequence, t sub 1 is when k equals 1. So according to this formula, t sub 1 equals t sub 0 plus 3 times 1 plus 1, which is t sub 0 plus 4. Now let's calculate t sub 2 using the recurrence relation. T sub 2 is t sub 1 plus 3 times 2 plus 1. But then we can back substitute our solution for t sub 1 into this equation to get t sub 0 plus 4 plus 3 times 2 plus 1. Now, what I noticed was that in the last formula we had a 3 times 1, and now we have a 3 times 2. But earlier, I combined the 3 times 1 with a plus 1 to get a 4. I'm realizing now that I shouldn't do it that way. What we should do is we should actually keep t sub 1 unsimplified completely so that we can more easily identify this pattern when we write t sub 2. So now when we rewrite this, this will be t sub 0 plus 3 times 1 plus 1, and then plus 3 times 2 plus 1. But I'm going to rewrite t sub 2 in a different way so that we can see the pattern a little bit more clearly. Here we have t sub 0 plus 1 plus 1. I'll group together the plus 1s. And then we also have a plus 3 times 1 plus 3 times 2. Next, we can find t sub 3. Although I think we can see the pattern now. I bet you t sub 3 is going to be t sub 0 plus 1 plus 1 plus 1, and then plus 3 times 1 plus 3 times 2 plus 3 times 3, and then it's just going to continue from there. Now, in general, the number of 1s we have is just the same as the index value. So if the index is 2, then there's going to be 2 plus 1s. And if the index is 1, then there's only going to be 1 plus 1. So we can generalize this formula to t sub n equals t sub 0 plus n. That's the plus 1 plus 1 plus 1 plus 1 plus 1 n times. And then here we have a series. Each term here has a factor of 3, so we can rewrite this as 3 times 1 plus 2 plus 3 plus ... And it looks like the last term with a factor of 3 will be 3 times n, whatever the value of the index variable is. Now, in a previous video, we actually learned what this sum is. This is just n times n plus 1 over 2. So we can simplify this even further to t sub 0 plus n plus 3n times n plus 1 over 2. And t sub 0 is 0. So now that we've generalized the formula, we can plug in t sub 0 equals 0 to get t sub n equals n plus 3n times n plus 1 all over 2. And I guess we could simplify this a little bit more. This is the same thing as 3 halves n squared plus 5 halves n. But I think that either expression here is a good explicit formula for t sub n. Thanks, everyone, and I'll see you in the next video.